Good day, guys, and welcome to the introduction to programming in C++ of the diverse Node Mobility Front-End Development Program. So today we will be discussing Chapter 2, Part 2 that talks about array. So here, going to share my screen to you guys. Right. So let's define array and why. It may be that we have to read, store, process, and finally print dozens, maybe hundreds, perhaps thousands of numbers. What then? Must we declare a separate variable for each value? Will we have to spend long hours writing statements like the one on the right, like this int var 2, 3, 4, 5, 6, 7, and so on? If you don't think that this is a complicated task, then we suggest you to take a piece of paper and write a program that reads 5 numbers of type in and prints them in order from the smallest to the largest. So this is the type of processing called sorting. We don't think you will have enough surface space on your paper for the task. So far, we have declared variables that are able to store exactly one given value at a time. These variables are called scalars and are analogous to mathematical terms. All the variables we have used so far are actually scalars. Think of how convenient it would be if we were able to declare a variable that could store more than one value. For example, 100 or 1000 or even 10,000. It would still be one and same variable but very wide and spacious. Should we just number them? And we will say, give me the value number 2, and assign the value number 15 and increase the value number by 10,000. It is probably a good idea, wouldn't it say? We will show you how to declare such multi-value variables. We will do this in the example we have used before. So we read this record as follows. We create a variable called numbers. It is intended to store 5 here, as you can see. Note that the number is enclosed by brackets and values of type int. Okay, so which we know that the keyword at the beginning is int in the declaration. So let us say that the same thing in the more technical terminology. Numbers is an array of consisting 5 values of type int. Since such an array is called a vector, in mathematical terms, we will also say that this statement declares an int vector of size equal to 5. All the elements of an array have the same type. So time for all intriguing curiosity. The C++ language has a convention which says that the elements in an array are numbered starting from 0. This means that the items stored at the beginning of the array will have the number 0. Since there are 5 elements in our array, the last one has the number 4. Don't forget about this. You will need it when you make your own arrays. But don't worry, you will soon get used to it and it will become natural to you. Before we go any further, we have to note that the following: our vector is a collection of elements. Of each element is a scalar. So how do we assign a value to a chosen element of an array? Let us assign the value of 1, 1, 1, 1 to the first element of the array. We do it in this way. So the first element will be 0. So the value of it is 1, 1, 1, 1. So that is how we assign the value of 1, 1, 1 to the first element of the array. So we need a value stored in the third element of the array, and we want to assign it to the variable I. This is how we can do it. So I is equals to numbers, and then we have the third element, since the first element is considered 0 in the array, right? And now we want the value of the fifth element to be copied in the second element. So can you guess how to do it? So the fifth element is number 4. So this is the fifth element, and the second element is 1. Okay, so since the first element is not 1 but 0, the value inside the brackets which selects one element of the vector is called an index. So here's the index, while the operation of the selecting an element from the array is known as indexing. Note, all the indices we have used so far are literals. Their value are fixed at runtime, but any expression could be the index too. This opens up lots of opportunities. So we want to calculate the sum of all values stored in the numbers array. We declared a variable where the sum will be stored and initially assign a value of 0 to it. Its name is sum. Then we add to it all the elements of the array using for loop, which is great tool for processing arrays. Take a look in the snippet. So here is the for loop, right? And then we have assign and we have array numbers and we have a 6 element, and then sum is equivalent to 0, and then we have declared a for loop here, and here's we have declared a variable called I, and this is for initialization equals to 0, and we have I is less than 5, and then I increment. Then we have an expression here, which is sum is equals to sum plus numbers I. Okay, so let us talk about this example for a moment. The I variable will take the values 0, 1, 2, 3, 4 subsequently and will index the numbers array by selecting subsequent element. The first, second, third, fourth, and fifth, each of this element will be added by the plus equal operator to the sum variable, giving the final result at the end of the loop. So the next task is to assign the same value, for example 2012, to all elements in the array. So how will you assign it? So here we have int numbers, then 5. We have 4 loop here and declared I is equals to 0, and then limiting it by I is less than 5, and then I increment. So from the numbers here, this variable, it is considered as 5, right? And the value of it is 0, and it will be incremented until 4. All right, so that would be all of this will be equals to 2012. So the description of this task is assign the same value, which is 2012, to all of the elements in the array. So all of the numbers, all the arrays will be equals to 2012. Now let us try to rearrange the elements of the array. Example, reverse the order of the element. The first and the fifth, as well as the second and fourth elements, will be swapped. The third one will remain untouched. Okay, so the question is, how can we swap the values of two variables? So let us look at the snippet. If we do something like this, we would lose the value we stored previously in a variable 2. So changing the order of the assignments won't help us either. So unfortunately, we need a third variable that serves an auxiliary storage. All right, so we have an auxiliary storage here. Unfortunately, we don't have an auxiliary storage. So we need a third variable. Okay, so this is how we do it. So we have an auxiliary variable, we name it auxiliary. So auxiliary is equals to variable 1, and then variable 1 will be equals to variable 2, and variable 2 will be equals to auxiliary. So that is how to reverse the orders of the element in the first and the fifth case. So that is how we swap them. We need to have auxiliary variable. So we don't know what you think, but we definitely don't like how it is done. It is still acceptable with an array of 5 elements, but with 99 elements, it certainly wouldn't be. So this is, as you can see here in the snippet, auxiliary is equals to number 0 is equals to numbers 4 is equals to auxiliary. So that is how we swap elements of number 1 and number 5. How about swap elements number 2 and number 4? So this is how we do it. We also use another auxiliary variable here. Auxiliary is equals to number 1. The number 1 is equals to number 3 array. Number 3 is equals to auxiliary. But if we have a 99 element, we cannot do that there. Let us use the services of a for loop. Look carefully at how we manipulate the indices values. During the first turn of the loop, the I variable will be equal to 0, so the instruction in the body will actually perform the following operations. So auxiliary is equals to number 0, and number 0 is numbers 4, and numbers 4 is equals to auxiliary. At the second turn, I will be equals to number 1, so auxiliary is equals to numbers 1 is equals to numbers 3, and numbers 3 is equals to auxiliary. As you can see, in the loop does the same job by shortening the code and making it more readable. So this is how we do it by using for loop. So this is okay. So first we have declared auxiliary here equals numbers I. Since this is a variable, we have initiate in the initialization, and first we just copy this one, numbers I is equals to numbers 4, and then since this is uh, we will use subtraction here, so 4 minus I, right? So numbers 4 minus I is equals to auxiliary. So yes, you can initiate arrays, assign initial values to them at the time of the declaration. We do this slightly different than the initiation of scalars because we need to specify more than one value. The syntax of an array, to be precise, a vector initiator, is clear and legible. Imagine that we want to create an array where the value of any element is equal to its index. A suitable initiator would look like this. So as you can see in the vector initiator, it is simply list and the value enclosed by curly brackets. Okay, so don't forget the semicolon after. And then if you provide fewer values than the size of an array like this, nothing bad will happen. The compiler just determined that those elements you didn't specify any value to be set should be 0. So if you provide more elements that can be stored in an array like this, it will be an error, all right? So it is okay to have lesser values than more than elements than the declared um, indices, right? So the compiler will be most dissatisfied. So one more example, look at this. We didn't specify the size of the array, but provided an initiator. See here, as you can see, we don't have an initiator here, but we have a 7 values. So this is legal, and it will force the compiler to assume that the size of the array is the same as the line of the initiator. The vector array will be declared in the following way. So the compiler will read it just like this. Okay, so it is okay to do. If you forget to have an initiator, it's okay, but don't forget to put more than values than the initiator. So far, we have discussed vectors whose elements are type int only. Don't worry, you can also use arrays of any other type. So for example, this is an array in which you can store 10 floating point number values. So here we have float, and then the name of our array is float r, and then we have 10, okay? So, and you can store 20 characters here. Okay, so let's check. Okay, char, and then surname, we have this. Okay. So as well as the logical Boolean values, virtually every piece of data can be aggregated into an array. even an array. We will show you that soon. So we have bool and then votes 100. Okay, so we have assumed thus far that arrays consist of scalars, but in fact arrays can contain elements of much more complex structure. Let us consider the case when the array's elements are just arrays. Surprising? Not at all. We often meet such arrays in our lives. Probably the best example of this is the chessboard. What we are going to say now will probably outrage experienced chess players, so we apologize in advance for all our simplification and inaccuracy. So a chessboard is made up of rows and columns, right? So there are 8 columns and 8 columns, 8 rows and 8 columns. I mean, so each column is marked with the letters A through H, and each line is marked with the numbers 1 through 8. So you can identify the location of each filled by letters and digit pairs. So therefore, we know that the bottom right corner of the board, the one with the white hook, is A1. So while the opposite corner is H8. So let us assume that we can use the selected values to represent any um, chess piece. So we can also assume that every row has on the chessboard is a vector. So let us try to declare it. Here it is. So we have int and then row number 8. So unfortunately, we have 8 of these rows. Does this mean that we have to declare the 8 arrays like this? So int row 1 and then 8, array 2, 8, row 3, 8, row 4, 8, 5, 8, 6, 8, 7, 8, and 8, 8, 8. Are you getting the sense of deja vu? We have already encountered a similar dilemma when we were searching the reason to use the vector. The chessboard is in fact an 8 element array of elements in a single row. Let us summarize. So first, element of rows are fields and 8 of them per row. Elements of the chessboard are rows and 8 of them per chessboard. So we are now ready to create an array for the chessboard, and here's the declaration. So in chessboard, then 8, then 8. This is for row and this is for column. So the chessboard variable is so-called two-dimensional array. So it is called by way of analogy to algebra matrix. The two pairs of brackets tell the compiler that the declared array is not a vector. It is an array whose elements are vectors. So access to any selected field on our board requires 2 indices. The first selects the row and the second the field number inside the row, which is de facto a column number. So look at a beautiful chessboard. Every field contains a pair of indices that needs to be given to our access to fields content. Okay, as you can see in the board, we have a row from numbers 1 to 8, and we have columns from A to H. So glancing at the figure here, we can set some chess pieces on our board. First, let us add all the rooks. So since in the chessboard we have 4 rooks, right? Okay, so the first one is we have chessboard 00, chessboard 07, and then chessboard 70, and then chessboard 77. Here we will place our rook. Okay, so if we want to place a knight on c4, we would do it as follows. So how to place the knight on c4? So chessboard 3 and then 2. So moving our knight to 3, 2 here. Okay, and then and now upon on e5. Where's the e5 here? E5, and then chessboard 4 here, and that's it. Checkmate, right? So now let's go deeper now into the multi-dimensional nature of arrays. To find any elements of the two-dimensional arrays, we have to use two coordinates, a vertical row number and a horizontal column number. So imagine that we are developing a piece of software for an automatic weather station. The device records the air temperature on an hourly basis and does it throughout the month. This gives us a total of 24 times 32 is equals to 744 values. So let us try to design an array capable of storing all these results. So first we have to decide which data type would be best for this application. So we think that a float would be best since our thermometer is able to measure the temperature with an accuracy of zero point 0.1 degrees centigrade. So next, we arbitrarily decided the rows will record the readings every hour on the error. So the row will have the 24 elements and each of the rows will assign to one day of the month. So we need 31 rows. So here's the declaration. So we have temp, 31, and 24. This is for the days in the month and 24 for every hour. Uh, yeah. All right, so now we will try to determine the monthly average noon temperature. We will add all 31 readings recorded at noon and divide the sum by 31. So we are assuming that the midnight temperature is stored first. So here's the relevant code along with the necessary declaration. Okay, so we have used the declaration float temp 31 24, and we have sum is equals to 0 point 0, and we also have average as a float here as a variable, right? So we have declared also a for loop for int day is equals to 0 and day is less than 31, and then day plus plus. And then we have sum plus equals temperature, and then this two-dimensional array, and then day, and then 11. So average is equals to sum divided by 31, and then see out average temperature at noon is average. So the average will, you will get average since the expression of this is sum divided by 31. So now let us find the highest temperature during the whole month. So let us see the code here. Okay, so we have the whole month, right? So temp 31 to the 4, then float max is equals to negative 100.0. We have a 2 for loop here, and inside of it we have if conditional statement. So in the first loop we have in day is equals to 0, and then day is less than 31, and then day increment. Another for loop we have, this is for hour, int hour is equals to 0 and r is less than 24, r increment, and then we have if conditional statement here, if temp and then day hour, so this is two-dimensional array, is greater than max, and then max is equals to temp, day, and hour, and then the highest temperature was max. So how do we get that max? So this is the expression for max. So now we want to count the days when the temperature at noon was at least 20 degrees centigrade. So we have float temp 31, 24, and then hot days. So this is 20, right? So for in days equals to 0, day and is less than 31, and day is increment. If temp day 11 is greater than or equal to 20, then hot days increment. So see out hot days. How do we get that hot days? This is how we increment by using the if else and for loop for limiting where we will stop. Okay, so days were hot. So we are going to fill the entire arrays with zeros in order to prepare it for use in coming month. So we have float temp 31, 24, int d, and the h for day and hour. We have two for loop here. This equals to 0 and d is less than 31. Increment for loop for h is equals to 0, h is less than 24, and h plus plus or increment. So we have temp two-dimensional array here for temperature, and then equals to 0.0. So the C++ language does not limit the number of the array's dimensions. So here you can see an example of three-dimensional array. And imagine at a hotel, this is a huge hotel consisting of three buildings, 15 floors each, and there are 20 rooms on each floor. So we need an array capable of collecting and processing information on the number of guests registered in each room. So step one, the type of the array's element, we think that int would be a good choice, although it should be unsigned to, as there's no such thing as a negative number of guests, right? So the second step is calmly analyze the situation, summarize the available information, three towers or buildings, 15 floors, 20 rooms. So now we can write the declaration as int guest and then 3, 15, 20. 3 is for buildings, 15 is for floors, 20 is for rooms. All right, so the first index is 0 through 2. So selecting one of the buildings, the second 0 through 14 and selects the floor. The third is 0 through 19 that selects the room number. Now we can book a room for two newlyweds in the second building on the 10th floor, room 14. We have guest 1, 9, 13 is equals to 2. So and release the second room in the fifth floor located in the first building. So we have 0, 4, 1 is equals to 0. So how do we get that? In the second room, in the fifth floor, and in the first building. So here, let us see in the room 14 in the 10th floor in the second building. We have two newlyweds and release the guest. Okay, so before we wrap up this out of our course, let us check if there are any vacancy on the 15th floor and the third building. How do we get that? So we have int room int vacancy is equals to 0, and then for loop where room is equals to 0 and room is less than 20 and room increment. So if guest is 214 room and then equals to 0, then vacancy plus plus. So the vacancy variable contains 0 if all the rooms are occupied of available rooms is 0. So we have structures. Why do we need them? So before we start going on about structures, we need to tell you about completely new type and name string. So for now, we are not going to tell you any more than what we use it for and how we declared variables on this type. So we promise we will give you more details in a separate section devoted exclusively to string, and we will show you how to manipulate them and how to enjoy using them. But to be honest, a string is little more than a type, and all we want to tell you at this point is that variables of type strings are able to store strings of characters like surnames, family names, street names, and all of the names, I mean, you can think of, including RD, R2D2. So variables of type string may be assigned with the same operators as any other variable we have previously encountered. So for example, we want to store the name of the favorite dish in the string type. We do it in the following way. So string student name, student underscore name, then we have 100,000. So, okay, so we have string dish underscore to underscore order, we have equals to pizza. So don't forget the double quote, okay, for close and open. So imagine that we as the developers have the following job to do. We are obliged to design a data structure that can store information about students attending our course. We need to store the name of each student, their time spent studying the chapters, and numbers of the last completed chapter. So we know that the total number of students will not exceed 100,000, and this leads us to write the following declaration here that allows us to store the 100,000 names, and then us try to manipulate that array. For example, suppose that the first registered student is Mr. Bond, James Bond. Let us store the information in our array. So how to store it? In the first student, student underscore name 0 is equals to Bond. with a double quote. Okay, so here, the time spent on a site will be stored as a float. This is not particularly obvious of or convenient, but we can certainly deal with it. So the number of hours will be represented as a decimal fraction. This leads us directly to the following statement. So float a student underscore time and then 100,000. So we know that Mr. Bond has spent 3 hours and 30 minutes studying our course. Let us denote that this is the following way. Student underscore time is equals to 0 is student time 0, which is 1, since he is the first student, equals to 3.5. So note that 3 hours and 30 minutes is equals to 3.5 hours, thus 3.5. So the main issue here is that the data concerning the same value, a student, is dispersed between three variables, although it should logically exist as a consolidated unit. Handling multiple arrays is cumbersome and error prone. And when life forces us to collect additional information, we are going to need declare another array and make a lot of other changes throughout the program. We don't like it, and you can be sure you won't like it either. So we already know what an array is. The array is an aggregated of array elements, and the elements are numbered and are of the same type. So can we use an aggregate whose elements could be of different types? So could they be identified by names, not by numbers? And is it a good idea? Yes, it is a great idea. This magical aggregate is called a structure. So a structure can obtain any number of any elements of any type. So each of these elements is called a field. So each field is identified by its name, not by its number. So clearly that the field name must be unique and cannot be doubled. Within a single structure, we will show you how to declare the structure appropriate to our needs. We will explain its meaning. So here's in the first declaration of our first structure, we have struct then student string name float time then int recent chapter. So first, the declaration of the structure always start with a keyword struct. So struct is a reserved keyword. So there is so-called struct tag after the keyword student in this case. So that is, uh, it is the name of the structure itself. So that is the structure name. There is a widely accepted custom of composing structure tags with capital letters simply to distinguish them from ordinary variables. So here comes the opening curly bracket as a signal that this declaration of field begins at this point. So after the name of the structure, we will have the curly bracket, and that is the beginning of the field. So our structure has three fields here in this example. The first is a string, and it is called name. And the second is a float, and it is called time. And the third is int, and it is called recent chapter. So the declaration ends with a closing curly bracket followed by a semicolon. Okay, so it have semicolon. So we want to emphasize that the previous declaration doesn't create a variable, but only describes the structure we are going to use in our program. If we want to declare a variable as a structure, we can do it in one of the possible ways. We have struct student, then stdnt, student, stdnt2. So that this is the two possible ways on how to declare structure. So this declaration sets up two variables, structured variables. So name stdnt and stdnt2 respectively. The variables are of type struct student and just student. Notice the structure declaration creates new type name. So we know that this variable consists of three name fields, but we don't know yet how to access them. As the C++ language offers a specialized indexing operator bracket for arrays, it also gives us so-called selection operator. So the sign for structure and is denoted as a single character dot. So the priority of the selection operator is very high, equal to the priority of the bracket operator. So it is a binary operator. Its left argument must be identify the structure while the right one must be the name of the field known in the structure. So the result of this operator is the selected field of the structure, and therefore the expression containing this operator is sometimes called a selector. So we have here its selector operator dot. This means the selector here results in the selection of the field called name. Uh, time. The type of this expression is the type of the selected field and is an I value. So consequently, we can use both of these selectors. Student.time is equals to 1.5 and float t is equals to std and t that time. So virtually, any data can be used as structures field, scalars, arrays, and pretty much almost all of the structures. So we say almost because the structure cannot be a field itself. So we can aggregate structures inside an array. So if we want to declare an array of student structures, we can do it in this way. So student stdnt as 100,000. Access to the selected fields requires two subsequent operations. First, in the first step, the bracket operator will index the array in order to access the structure we need. In the second step, the selection operator selects the desired field. So this means that if we want to select the time field of the fourth stdnt as element, we will write it like this. So stdnt as 3 and the fourth, this is the fourth element, that time. Okay, so we now collect all these assignments that are performed for three separate arrays. Look at them carefully. So student 0 name is equals to 1, student 0 the time is equals to 3.5, students 0 the recent underscore chapter is equals to 4. So for the purposes of further consideration, we will use a simple structure designed to store the date. It is equipped with three fields and each of type in name, year, month, and day, so which clearly denote their role and purpose. The first possible way of declaring the structure is here. So struct and then date, we have in month and day. So of course we can write this declaration much more compactly. Okay, so struct date in here month day. Just add comma. So both variants are the same. This declaration doesn't create any new variables, but only announces the compiler our intention to use this structure tag to declare new variables. So the new variable would declare, for example, in this way, date of birth. So we can use it to store Harry Potter's date of birth that year is equals to 1970, 1980, date of birth that month is equals to 7, date of birth day is equals to 31. So we can also use the structure that to declare an array of structures. So we have date, visits, and then 100. So accessing a single structure stored in the array is easy. If we want to declare the data of the first visit, we do this. So visits 0 that year is equals to 2012, visit 0 that month is equals to 1, visit 0 that day is equals to 1. So we can also kill two birds with one stone by defining the structure tag and declaring any number of variable simultaneously in the same statement like this. So struct date int year, date, month, day, and then date of birth, visits 100, date, current underscore date. So we can also omit the tag, declare the variables only, struct int, date, month, day, and then the end of the world. Okay, so in this case, however, it becomes harder to determine the type of the variable, the end of the world. So without a tag, we have to denote it as size of, then parenthesis, struct, and then int year, month, and day. So we think this is a way too complex and unreadable. So compare to size of struct date. So a structure can be a field inside another structure. Imagine that we have to extend our student structure and add a field to save the date of when a particular student visited the course last time. We can do it in this way. So struct student string, name, float, time, interest, and underscore, chapter, struck, date, last visit, then Harry Potter. So it means that we will have to use two subsequent selection operations to go deeper in the structure. Uh, First, we select a structure within the structure, and then we select the desired field of the inner structure. So this is how it works. So Harry that last underscore visit that year is equals to 2012. Harry Potter that last underscore visit that month is equals to 12, and Harry Potter that last visit underscore visit that day is equals to 21. So when did Harry Potter visit us? So it is December 21, 2012. Okay, so here we have declaring and initializing structures. So as structures, field names may overlap with the tag names, and that is not a problem. Although it may cause you some difficulty in reading and understanding the program, the snippet is here. This is completely correct, a snippet. So here's struct, then we have struct, all caps, and int struct structure. So structure dot struct is equals to 0. So the struct here, all caps, is a field name, right? So it may be the case that a particular compiler you are working with doesn't like it, and when a structure's tag name overlaps with a variable's name, then therefore it is better to avoid tricks like the ones here. So struct, then the str in field structure, then int str structure that field is equals to 0, str is equals to. So alternatively, get yourself a new compiler, one that doesn't complain so much. So two structures can contain fields with the same names. So the following snippet is correct. Structs int f1 str1 struct, then char f1 str2 str1 dot f1 is equals to 32, insert str2 dot f is equals to str1 dot f1. So you can initialize your structures as early as the time at the time of declaration. The structures initiator is enclosed in curly brackets and contain a list of values assigned to the subsequent fields starting from the first. So the values listed in the initiator need to conform to the types of fields. If the initiator contains fewer elements than the number of structures field, it is presumed that the list is implicitly extended with zeros. If this particular field is an array or a structure, it should have its own initiator. If the internal initiator is complete, we can omit the surrounding curly brackets. Take a look at the example. So here, as you can see, struct date, then we have date, and equals 2012, 12, and 21. The initiator is equivalent to the following sequence of assignment. Date that year is equals to 2012, date that month is equals to 12, and date that day is equals to 21. So the initiator of this form is functionally equivalent to the following assignment. He that name is equals to 1, he that time is equals to 3.5, he that recent chapter is equals to 4, he that last visit that year is equals to 2012, he that last underscore visit month is equals to 12, and he last visit that day is equals to 21. Due to the completeness of the inner initializer, we can write the following simplified form. Student he is equals to 1, 3.5, 4, 2012, 12, and 21. So this simplification or omitting the internal curly brackets cannot be applied in the following case. So we have student she is equals to Matahari, 12 dot, then 12, and then another curly braces, 2012. So the internal initiator referring to the last visit field doesn't cover all the field. This means that it will be equivalent to the following sequence of assignment. She that name is equals to Matahari, she that time is equals to 12 point, she that present chapter is equals to 12, she that let's visit year is equals to 2012, and she let's visit that month is equals to 0. She let's visit that day is equals to 0. So we have here the structure as struct student he is equals to bond 3.5 4, then 2012, another curly brace 2012, then 12, 21. So this is just the specification of the last visit. So what happens when we apply such an empty initializer? This is what happened. The student nobody is equals to curly bracket empty. So nobody name is equals to coded, then this is just empty, and then nobody that times equals to 0, 0.0, nobody that recent chapter is equals to 0, and nobody that last visit year is equals to 0, nobody dot last visit dot month is equals to 0, nobody dot last visit dot day is equals to 0. So guys, welcome to the module quiz, module 2 quiz and module 2 test. Today you will answer 10 questions, and it will you will take it in 25 minutes. So good luck guys, and after you answer the module 2 quiz or the chapter 2 quiz, you are going to answer the chapter 2 test. So guys, this concludes the chapter 2, part 2 of the Diverse Not Mobility Front End Development Program. Have a good day and goodbye. Thank you.